the amazing thing is that every atom in your body came from a star that exploded. And the atoms in your left hand probably came from a different star than in your right hand. It really is the most poetic thing I know about physics. You are all stardust. You couldn't be here if the stars hadn't exploded, because the elements, the carbon, the nitrogen, the oxygen, the iron, all of the things that matter for evolution weren't created at the beginning of time. They were created in the nuclear furnaces of stars. And the only way they could get into your body is if those stars were kind enough to explode. So forget Jesus. The stars died so that you could be here today. And if you know who said that, you are one step ahead of Steve. Hello, Steve.
I do know who said that, actually, but yes. But hi, Kyle.
Do you?
I do.
It's good to be back. It's good to be back.
I've read it.
I missed you guys, but let's say hello to our two esteemed guests here. Bill Ludlow, welcome back.
Thank you. Welcome. Glad to have you. Glad you're having me.
Sure. And after this initial chat, I will formally introduce both of you, but I just want to say hello to you both real quick. And of course, our esteemed guest of honor, Dr. Lawrence Krauss. Welcome to the show, sir.
It's great to be here virtually.
I'm not going to waste much time with the announcements like I usually do. Just to say that on March the 4th, which is next Monday, Dr. Grady McMurdy will be here, and he will be having a conversation with Aaron Ra. Steve, you kind of want to sum up Dr. McMurdy's position?
Yeah,
or what he...
Dr. McMurdy's like the discount version of Ken Hovind. We've had him on before. He runs the same type of script, same type of narrative. I'm really looking forward to seeing what Aaron has, because we remember when Aaron and Hovind had their discussion. It was brutal. It was epic. I don't know what McMurdy's going to bring to the table, because it seems to run the same exact script, but I'm going to enjoy the hell out of it and be bringing popcorn and whiskey. So,
yep. And I know that you guys in the chat are going to have a lot of questions. We will, of course, do the super chats first and get to as many as we can. We're going to stick to around an hour-ish, so just keep that in mind. But we will try to get your questions in towards the end. And now Bill has been with us quite a few times before, so he is no stranger to the channel. But just in case you're watching for the first time, Bill studied at Lansing Community College and Michigan State University, and has been an avid amateur geologist, paleontologist, and fossil collector for many years. His interest in the creation-evolution controversy began in college during discussions with classmates, and grew after discovering internet forums, and more recently, Facebook groups dedicated to the subject. He spends most of his time in the field in Arizona studying the landscape, searching for fossils, and also fishing whenever possible. He is a member of the Geological Society of America, the Southwest Paleontological Society, and the National Center for Science Education. And you currently, Bill, are adding onto that resume with your work that you're doing now. Do you kind of want to give people a quick introduction about what you're doing, that special project you got going on?
Well, I kind of want to get into that when I start talking about citizen science.
Sure.
Yeah, I'll kind of segue into that. So,
okay,
because that has a lot to do with that. So.
We'll table that then. And let me. I pulled out with Dr. Krauss. It's hard to sort of piece together a resume that will do him justice, I think, because it's so lengthy. But I'm going to attempt to. I'm going to attempt to do that. He received his undergraduate degree in mathematics and physics from Carleton University, his PhD from the Massachusetts Institute of Technology in 1982. After a stint in the Harvard Society of Fellows, he became an assistant professor at Yale University in 1985 and associate professor in 1988. In 1993, he became the Ambrose Swayze Professor of Physics, Professor of Astronomy, and Chairman of the Physics Department at Case Western Reserve University. In August 2008, he joined the faculty at Arizona State University as Foundation Professor in the School of Earth and Space Exploration and the Department of Physics in the College of Liberal Arts and Sciences, and the Director of the university's Origins Initiative. In 2009, he was inaugurated with this initiative at the Origin Symposium, in which 80 of the world's leading scientists participated and 3,000 people attended. He is strongly committed to public understanding of science and has helped lead the national effort to preserve sound science teaching, including the teaching of evolution, for which he was awarded the National Science Board's Awards for the Public Understanding of Science. With over 10 books, including The Greatest Story Ever Told So Far and A Universe from Nothing, the one, the only Dr. Lawrence Krauss.
Great. I think there's no time for the rest of the show. I think we have to go now.
You know what, though?
Thank you all for joining us tonight.
That's not even half of the accolades that you have, though. I mean, you have quite the impressive career. So, Steve,
good on paper.
You are the physics guy here, and so I'm going to let you kind of kick us off and get us started talking.
Well, don't bring him on the spot. I'm not like a physics guy like Dr. Krauss is a physics guy. My background was in nuclear stuff, but that was many, many eons ago. But I have read his book before, and actually reread it kind of last night as well. It's actually one of my favorite books as far as explaining very complex things relating to cosmology and Big Bang and the whole something from nothing. And I think it's a great book as far as relating to the layperson and the person who knows a little bit about physics. And hopefully I can kind of guide this portion of it where I've had people ask me questions to ask you and relate it to a way that the outside people listening can understand, because the book is written, I think, in a way, and I don't know if this was, but it is designed. This is one of the questions I want to ask you. Is it designed to not only appeal to people that may not be that physics minded, or is it something more mid-level that can appeal to both the layperson and to professionals? Because it's a lot of information in that book.
Well, I try to. It's hard to reach everyone or satisfy everyone when you write anything. But with my books, I try to have something in there for everyone. I try to explain things at a basic level where someone without a lot of background can get a general perspective. And then there are parts of every book, because I think you have to be honest about when science is complex, to try and explain it and don't dumb it down too much, to try it in those sections to challenge people. But I try to make it so if you're willing to puzzle through, you can get much of it. But I like to try and challenge everyone from the layperson who may not have any experience to people who've read a lot of science books. I think with the books, what I try and do more is motivate and give a perspective, so that I don't expect anyone to come out of reading my book as a physicist, but I hope that they'll understand the central issues, and that every now and then they'll be puzzled, because the world is puzzling, and it's worth pondering a little bit. So I certainly try and reach as broad an audience as possible, but in every book there are little bits of challenge, and I always try and also write a book so that if there's a part you don't really get, generally I try and write the book so that you can skip over that and you won't lose the rest of the thread. And I think that's really important, both in writing and in lecturing, because we all, when we're listening to lectures, we all daydream and about every 7 or 8 minutes, and it's important to not suddenly lose the whole context of the lecture. So I try and, in my writing and in my lectures, try and set things up so that when you were daydreaming or thinking about your mother or whatever you do, you don't lose the whole rest of the talk or the whole rest of the book.
Yeah, I think it flows well, and I probably understood 80%, which I think is pretty good.
That's pretty good, I guess. I'm not sure I understand.
Yeah, I mean, of what you've written. I mean, as far as the actual topic, nowhere close.
I meant what I said. Anyway, go on.
But for example, one of the things that I do want to ask about, I see this frequently. Everybody here has dealt with creationists. Bill Ludlow actually got introduced to the world by having a debate with Ken Hovind on my channel. We all have a very
condolences.
What's that?
It went well.
It's okay.
Yeah. Anyway, I had to sit through it. That's not the first debate I had to sit through with Ken Hovind. So yes, please feel bad for me. But we noticed one thing that's kind of a persuasive, or not persuasive, permeating these discussions with creationists is that when they talk about your book and they talk about these papers dealing with something from nothing, there's equivocation that they do every single time. And you make it very clear numerous times in your book what you're talking about. And I know you get asked this
I try to.
But you no, it's very clear. No,
how
you
many
do
people
make it
still
very
miss
clear.
it.
And I have to ask, one, I don't think they actually read what you write, if that's the case.
Yeah.
Or there must be.
No, they don't. They read what other people say. It's a real tendency. I'm sorry to interrupt, but I see this all the time.
No, please go ahead.
Is I read people say what other people say I write about in the book. So they'll say Lawrence Krauss says this because someone else says I said this, but if they actually read the book, it's not what I say. But I'm used to that. You know, people just read reviews and then immediately decide, or read their favorite person who doesn't like me or the book or whatever, and they'll decide that's what I say. But I try try and make it extremely clear what I say and what I don't say. But anyway, go on. Sorry to interrupt.
Yeah, no, and
Steve,
I do find that to be the case. Yes.
Let me, Steve. Can you? I think it might be good to get Dr. Krauss to state his position. You know, kind of sum it up when he says something from nothing.
Yeah. What you actually are referring to in the whole argument from?
Well, I read, as I say, I wrote a whole book about it. So but the idea is the central point of that book was, first of all, just to introduce people to the amazing revolutions that have taken place in cosmology over the last 40 years that have completely changed our picture of the universe that we live in, past, present, and future. Having said that, one of the big mysteries that especially religion has tried to usurp is this notion of something from nothing. And the point is that the very first things I try and point out is that the definitions of something and nothing are scientific terms. And those ideas have changed dramatically over the last 100 years, and particularly over the last 50 years. But the central premise is that you can create a universe with 100 billion galaxies, each containing 100 billion stars, and space and time, from no space, no time, no stars, no anything. It sounds like it requires divine intervention to get all this stuff when there's no stuff, but it turns out the laws of physics, as we understand them, and just gently extrapolated, but as we understand them, allow for the possibility of creating a universe where everything that we see did not exist and then came into existence. Moreover, if you ask what would be the characteristics of a universe that popped into existence with no space, no time, no matter, no radiation, everything else to begin with, and then suddenly a universe with space, time, matter, radiation, what would be the characteristics of such a universe if it lived 10 billion or 14 billion years? Turns out the characteristics of that universe would look precisely like our universe. Does that prove that our universe came from nothing? Absolutely not. But it shows that not only that it's plausible, but highly suggestive. And what it really means is that you don't need any supernatural shenanigans to explain how to get us from nothing. There's no need for any supernatural entities. And anytime you can remove that, that's a good thing. You can explain how we got here just by natural laws of science. And I liken it without the same pretense. I don't want me to sound pretentious in this sense. But when we don't understand all the details of exactly what happened at t=0, but we can argue plausibly from what we know and come up with what we see. It's really the same in that sense as when Charles Darwin developed evolution. He didn't know about the details of genetics or DNA or the human genome or any animal's genome. So there's a lot at the fundamental level he didn't know, but he demonstrated that the evidence was that you could get the diversity of species we see on Earth from simple beginnings by natural selection and mutations within a species, that those could naturally arise without any supernatural shenanigans in terms of everything we see. Moreover, all of the evidence that he collected, and of course all the evidence in the intervening 150 odd years, has been completely consistent with the predictions of that hypothesis. Just like all the evidence about the universe we see is completely consistent with the hypothesis that there's no intelligent design behind the universe as we see it. So that's maybe a rough summary of what that book was about.
No, and I like that fact that you had mentioned in your book that things make predictions. Like one of the things, like Wolfgang Pauli had predicted the neutrino long before, we knew that it existed. He looked at beta decay and said, "Hey, something's wrong here. We have to have conservation of the energy, momentum, and lepton number." And all he says, it has to be right. And so the same thing with Derek, with he posited antimatter, right? It has to exist. Now, I think you wrote this in your book, and this is new to me, that he actually posited the proton to be the antimatter to the electron, which I think is bizarre.
Yeah, he
never heard that
as
before.
he later on said, his equation was smarter than he was.
Right.
Because he, at the time, it was at a time when postulating the existence of new elementary particles was radical. Now it happens all the time. In the intervening time, we've discovered new particles all the time. And by the way, when Pauli invented or proposed the neutrino, I'm not sure he really believed it. He just said, this is what a radical thing that seems to be required, but until experiment demonstrated, or at least until other experiments indirectly suggested it was there, I'm not sure he believed it. But Dirac, this equation predicted the existence of antiparticles for all the particles we see, but he wasn't bold enough to suggest that was the case because no one had ever discovered new particles. But within 2 or 3 years of the time of that development of that equation, lots of new particles were discovered, including the antiparticle of the electron. And then, of course, over the 1950s, every time you banged new particles together at accelerators, other new particles created. And it would seem like there was no end or no rhyme or reason. It looked like it was just a soup of an infinite number of elementary particles. And one of the great things that I actually talk about in the book after The Universe from Nothing, but in The Greatest Story Ever Told, is how what our revolution was like at the fundamental smallest scales, not just the largest scales. And it's really an unsung story that our picture has changed more in the last 50 years than it did even before that with the developments of special relativity and quantum mechanics. We now understand this incredibly exotic world of elementary particle physics, and in fact the world around us, in terms of 4 basic forces, 3 of which we understand precisely. And gravity we understand not quantum mechanically, but classically. It's just an amazing development from the time I was a high school student and almost from the time I was a university student. At that time, we understood 1 of the 4 forces in nature. And now we understand 3 precisely, and we're trying to understand gravity a little more. And that's an amazing development in a single human lifetime. And of course, during that process, we took a world with lots of elementary particles that seemed to have no rhyme or reasons, and we now understand at a fundamental level, as far as we can see, there are these things called quarks, and there are these other particles which you mentioned called leptons, of which the electron is a particle, and that basically makes up. And then there are particles that convey the 4 forces, and this extra weird particle or set of particles called the Higgs particle. And that's it, as far as we can tell. That explains everything we've ever been able to see. It's an amazing triumph of the human intellect. And it saddens me that more people don't appreciate it, because it's really as poetic and beautiful as anything else humans have ever done. And
and the reason I brought that up is we have creationists who watch our show. I hate to say, but I'm actually friends with some of them. I mean, I don't think that.
Well, there's no reason not to be friends with people. Just I mean, disagree with them.
Exactly. And I'm really into building bridges, because I think that a lot of them.
I'm going to interrupt you one more time. Let me interrupt you one more time to reveal something that many of you may not know. There's a person who all of you are undoubtedly fans of, a late friend of mine, Christopher Hitchens, who of course debated creationists and many occasions, and debated believers in many occasions. But on a personal level, he was the most tolerant person I've ever known. He would regularly have to dinner at his house people who I would have a hard time being in the same building with. And his feeling was, I think that as individuals, you can respect someone as a human being and disagree with him completely. And he was a bulldog on stage, but he was an incredibly tolerant human being. So anyway, go on.
No, he was so classy. He was so classy.
Yeah, and he had a wonderful
accent. You have no
idea
how much shit I get for being friends with Saitan Brunicate. Okay, so yeah, I get that. Trust me. I mean, I get along with the guy. I honestly do. But anyways, the reason I bring that up is because of the creationists in the audience. When you make predictions, right? You were saying that these are the things that the mathematics are indicating, and so these are indicative of future things, like when we predicted the things like dark matter, right? Dark energy. These are things that are necessitated by the mathematics. So can you kind of explain to the listeners why is it that there are not just magical things out there?
Well, they're not just not magical, but people, one of the things that many creationists say, especially young Earth creationists, is this illusion that somehow astronomy and paleontology, for example, are historical sciences. But they're no more historical than physics or chemistry. In the sense, it's true that many of the things you do in astronomy and paleontology is to study things previously. But that's exactly what we do in the laboratory. What's really important is, based on what you see, you then make predictions about observations you have not yet made. You make predictions about fossils that you haven't yet seen. You may make predictions about the genetic relationships of mammals that you haven't yet tested by measuring their DNA. So even though you're looking at an evolutionary process that happened in the backwards in time, you're making predictions about observations that have not yet been done and could falsify your theory. And the same is true in astronomy and cosmology. Of course, we're trying to understand the ancient history of the universe, and it's true what they say, that people weren't around then, but that doesn't matter. Based on what we observe and the models we build, we can make predictions about things we haven't yet seen. And there are dozens of such predictions that we can test. The theory becomes falsifiable because we can make these predictions about things we haven't yet seen, whether it's the nature of dark energy or how large the early fluctuations would have been in the cosmic microwave background, and what we would expect to see about when galaxies formed. So all of these things, we're opening up new windows all the time with the Hubble Space Telescope and the Next Generation Space Telescope and the other satellites that have been set up, the new planet discovering satellites. So we're making tons of we have predictions, but we're in a golden age of observation where we can now make new tests of predictions we never thought would be testable. When I was even a young professor, I never thought we'd ever be able to know the expansion rate of the universe to the precision we do. I never thought we'd be able to directly see the early fluctuations in the microwave background, that we'd be able to measure the curvature of the universe. All of these things seemed like science fiction as a theorist, even though we made predictions about them. And I'm amazed that now we've been able to turn cosmology into a precision science where we can measure things not to an order of magnitude or a factor of 2, but in some cases to 5 decimal places, and compare that with the predictions of theory.
I personally have this is going to be more of a technical question, and only because I may never get a chance to ask you, so I'm going to throw it out there. Hopefully, it won't confuse the audience. But reading something like this, and I'm a little bit familiar with the topic. It's one of the things that's most difficult to wrap your head around. So I'm thinking that maybe people that have experienced this as well might have a hard time with this. And this goes with the concept of the free lunch. And so when you have this universe that's expanding and it's increasing in volume, and you have an energy distribution that's constant, but you have a total net energy going up, then you basically are. It seems like you're getting something from nothing.
You're getting something from nothing. Well, you are, yeah, but in a legal way.
It's hard to wrap your head around from that, though. It's like, how do you have this increase of energy out of nothing?
I'll tell you how. It won't satisfy you, but I'll tell you how. So it turns out the energy of empty space not only has energy, but it has pressure. Now, in elementary physics, you learn that when you have an expanding gas, or when you move some system, the work done is the pressure times the change in volume. That's elementary physics. But empty space has negative pressure if it has energy. And what it means is that as it's expanding, work is being done on empty space, not by empty space. And that work that's being done goes into precisely increasing the total energy contained in any volume as the volume increases. So it's the fact that there's this weird negative pressure that when space expands, instead of doing work, like when I blow up a balloon, all the particles in the balloon are doing work on the balloon to make it expand, okay? And they're doing work, and some of that work energy that they're doing gets released as heat and other things. But when the universe expands, instead of work being done by the expanding universe, work is being done on the expanding universe because of the negative pressure, and that's dumping energy into empty space so that there's more space, and empty space, the energy density of empty space remains constant, the volume increases, and therefore the total energy in some large volume increases. but that's because work's being done on empty space. I know it doesn't really, it may not seem to explain anything, but that's the physics and the mathematics of it.
It does, and ironically, somebody actually in our audience actually wanted that question asked. So you're welcome. No, it does, but it's
somebody.
It's really difficult to have a paradigm shift. Like, for example, my background was more classical. I operated nuclear power plants. I trained people to operate nuclear power plants. I'm straight billiard balls and electron going roundy around nucleus kind of stuff, right?
Well,
I mean, I get the other stuff, but I'm old fashioned. Yeah. So when you have to do this paradigm shift, and you have to think in a way of dealing with negative pressures and stuff like even negative gravity, if you can maybe touch on that. If you have, let's say you don't have a situation where you have potential energy converted to kinetic energy. You're not dropping something, but two spheres out in space somewhere, and they just have their own gravitational force, and they're being brought together by kinetic energy, or the kinetic energy is going up because they're being brought together. Now you've got to offset that with negative gravity. That's
well,
something that seems to be
potential energy goes down.
difficult.
No, that's pretty simple. But let me just say, look.
No, for some people, I get
it's
it.
okay.
But for some people, they have wrapping around.
I'll try and explain it. But look, the point is that none of this having a new window on the universe and a new picture of the universe doesn't come easily. It's not supposed to come easily, in the sense that, as I've often said, one of the purposes of education and science is to make you uncomfortable. Because if you're not uncomfortable, you're not expanding your horizons. And so every time we learn something about the universe, it may surprise us, and it takes us a long time to get our heads around it. And it's not surprising that some of these radical new ideas are hard to comprehend. You shouldn't feel bad if they are. They're hard for physicists to comprehend. And it takes time to get your mind around them, and generations. Often, Max Planck once said that physics proceeds one funeral at a time. Namely, the next generation finds it easier to understand the things that the generation before found very difficult. But the decrease in energy when things are falling together is not too surprising, because it's true. If I take this water bottle and I drop it, okay, it speeds up. But then it can do work on my table. If it was a full water bottle, it happens to be empty because I just finished drinking it. But if it was full or full of lead, I could have a nail on my table and drop it, and it would pound the nail in. In pounding the nail, it does work. So it's when it's up here, it has the potential to do work. It has more potential up here, because if the higher up it is, the more potential the greater it's going to eventually be able to have speed and knock a nail in. So the fact that things lose potential energy as they go down is not surprising. Now, the point is, an object out at infinity, far away from everything else and at rest, it makes sense to say that has zero total energy, mechanical energy. It's at rest, it's not moving, and it's infinitely far away from everything else. So let's say that it has zero total energy. But then if you move it closer to the Earth and it starts falling to the Earth, if its initial energy, potential energy, was zero, it's lost energy, and therefore its new potential energy is negative. And so gravity is full of talking about negative energy, because we define things at infinity to be zero. And so negative energy is an integral part of gravity. It may sound like hocus pocus, but it actually is relevant.
Yeah, I was going to go in more in detail with like some Hamiltonian operators and some other stuff that I would love to one day have a discussion with. But Bill, you have a question. Go for it, man.
I do. I'd like to say I love the beard. Okay, I love the beard.
Well, thank you.
Oh, his.
Yeah, I was just going to say, I've noticed that. I was going to say, it seems to be a requirement of being on the show.
Yeah. Well, and let the gray come in. Let the gray come in. It gives you an air of wisdom when you finally achieve that. So I see that starting.
My wife wishes it was all gray. But anyway,
don't fight it. Yeah.
Yeah, I'm not fighting.
I heard you say once that your daughter did a 4th grade project on Pluto as a planet. My daughter Lauren also did a project on Pluto as being a planet. So I just want to say, take that, Neil deGrasse Tyson. We're raising the next generation of
that's right. Every time I'm with Neil, I let him know that. Yeah, I mean, the point is, unfortunately, I mean, it's just a name, a planet. Pluto will always be a planet to me. But the point is, and Richard Feynman once said that his father took him out in the woods when he was younger, and he was looking at the birds, and he said, "What kind of bird is that? What kind of bird is that?" And his father said to him, the name doesn't matter. The name doesn't give you any information about the bird. What matters is how does the bird fly? What are its habits? How does it eat? How does it reproduce? Those things matter, but the name is irrelevant. And so Pluto is going to be Pluto, regardless of whether it's a planet or not. And in fact, I'm happy to say that there's probably two things I wanted to mention about that are happening coming up in this program. One is, as of today, in fact, as of about 20 minutes ago, the website for the new Origins program, the Origins Project Foundation, just went live. It's a new nonprofit we've created to continue the work of the Origins Project. And the Origins Project Foundation, you go to originsprojectfoundation.org, and as of today, you can go to the website and learn about the program. We're going to be running programs like we did before in big theaters, also travel opportunities for people. But another entity that we've just created, which is called the Origins Project LLC, is running something that we're about to call the Origins Podcast. And it's going to be a video podcast, and it's going to be quite amazing. The set of guests we have will range from everyone from 6 Nobel Prize winners to Woody Allen, in fact. But also, one of the early people we're going to have, and we're going to be taping it in a week or so, is Alan Stern, who was the head of the New Horizons project, which was the satellite that went past Pluto and taught us many new things about Pluto and now beyond. And what Alan, I'm sure, will agree with when we talk next week is that Pluto is more fascinating than it ever was. Whether or not it's a planet, we've learned that it's far more interesting, and that probably is all that matters.
Yeah.
What's? Oh, go ahead, Bill.
I was just going to say, my big question for you, because we've used a lot of time already. My big question for you is, in the history of human knowledge, our world has always gotten bigger. Written history started in the Middle East, we guess, a few thousand years ago. They only knew about their local region. A few thousand years later, we discovered that the region was bigger, and then we finally discovered the entire Earth. We looked to the stars and saw that we were part of a solar system, and that was our universe. And then we discovered galaxies, Then we discovered there's billions and billions of galaxies. So, it appears our universe is finite at this point, right? It's expanding, but it not finite. Well, it's expanding, but is there any reason to believe that the next big step is just going to be, again, much bigger? We're part of something much bigger. History tells us that that's always been the case.
Well, sure, as our horizons grow, as I've often said, and some people will have heard me say, every day I'm surprised if I'm not surprised. Because every time we open up in a new window in the universe, we discover new things we never saw before, whether it's increases in space or new things that happen in space. The universe becomes more and more interesting every time we look for new things. Now, it turns out we don't know if our universe is finite or infinite. We can only see a finite amount of it. And we used to think, when I was young, that the older the universe was, the more of it we'd be able to see. Because light travels at a finite speed, and therefore objects from a certain distance, we can only have seen them if the universe is old enough for that light to make it to us. And we figured, well, the older the universe is, the farther away will be the objects we can see. That was conventional wisdom. But as often happens, conventional wisdom isn't right. Because it turns out, as far as we can tell, the expansion of the universe is getting faster and faster. And that means that there are objects that are now moving away from us faster than light that we'll never be able to see. And in fact, the longer we wait, the less of the universe we're going to be able to see, because more and more regions will be moving away from us faster and faster as we wait over time. If that's true, then in some sense, as I often say, we better do cosmology now, because the longer we wait, the less we'll see. But we don't know if that's true. That expansion may end at some point. But that doesn't mean the universe itself, of course, is finite. And there could be, as I've written recently in professional papers and in some lectures, what's amazing is we may be able to do measurements of gravitational waves from the beginning of time that will tell us that other universes exist. And so our picture will suddenly leap in a much greater sense. Even though we'll never see them, we'll know that our universe isn't all there is, that there are in fact other universes. And that's the kind of leap that I think you might be talking about. So it's perfectly possible in my lifetime, in the lifetime of all the people in this program, that we may know indirectly that other universes exist. And again, I would have thought 20 years ago that that would be impossible. And that's just underestimating what observers can do.
My question would for you would be, in an age where things, pseudoscience issues like flat Earth, anti-vaxxers, various religions are starting to to gain traction and take hold. What's the greatest contribution that the average person can do to sort of get it off that track? Like, what can your average person do to contribute to the spread of actual evidence and facts, and kind of combat this trend that's going on?
Well, of course, that's a wonderful question. I wish I had a silver bullet to answer it. But what I think one of the big things that we can do is try and ask questions. Look, first of all, to some extent, we have to recognize that a certain generation is just beyond help.
Mm-hmm.
I mean, and that what we want to concentrate on are young people, because they're the future. And there we have to realize that I think we need to teach young people in a way that's too often different than it's being taught. We need to teach them by asking questions, not rote memorization or learning a set of facts, as used to be the case in some ways when I grew up. Because my iPhone has more facts, but it also has more falsehoods than you'll ever get in school. What you need to learn is how to tell the sense from the nonsense, the anti-vax nonsense from the sense. And to do that, you have to start asking questions and say, well, if this is the case, what does it imply? And then look to see if those predictions are satisfied. So it's a sense of learning how to be skeptical, learning how to constantly ask questions, and then learn how to seek the answers by seeing if your predictions correspond to reality. So I think we have to make learning a process of discovery. Instead of every time a child learns something new, for them it's the first time in the history of the universe that it's ever been understood. It's an amazing discovery. And so instead of worrying about the content so much, because people can get lots of stuff later on from the internet, if we have to teach people how to sift through what's sensible and not sensible in the internet and everywhere else, and that involves asking questions, testing your ideas, and then retesting your ideas. Now, you all know that, but what I think we can do when we talk, if we want to confront the average person wants to confront people who are spouting nonsense, ask them questions. Use the Socratic method. Say, okay, if this is true, then doesn't this predict this? And then isn't this different than what we see? And so lead people by questioning, as Socrates used to do. Is one good way, I think, of trying to counter this technique, and also encouraging your children to ask questions and be perfectly willing to say, I don't know. Let's find out. Instead of appearing to know, parents like to appear to know the answers to all their children's questions, and teachers do too. But it's much more fun to say, I don't know. Let's figure it out. Let's go on the internet and try and sift through the sense and nonsense and see what the actual answer is.
So what you're saying is there's nothing to this NASA lying to us about the shape of the Earth rhetoric, right?
No, yeah, but look, just saying it's wrong doesn't mean anything. So I've been on lots of radio programs where unfortunately journalists have said to me, "How do we know the Earth isn't flat?" And then you can ask questions. Well, how come my time zone is different than your time zone? Why is that the case? Why does the sun set at a different time for me than you? I mean, you can ask a whole bunch of questions, and eventually you're going to if you have enough questions, then it's going to become pretty clear that the assumption that the Earth is flat is just nonsense.
Excellent point.
If I can add too, I think the key that Lawrence hit on is we're not going to reach a certain generation. I think the older generation has their minds made up, and reaching children is really the key, and it's teaching them the thought process and the scientific method, and asking questions, but also reaching them and reaching out to them with science. I volunteer. I volunteered almost 300 hours last year at our local museum here, teaching human origins to children that come in on field trips. They may get evolution in school, but they don't get much of human origin, the specifics. And you gear your presentation to the age group that you're dealing with. My presentation to a 7-year-old is going to be different than my presentation to a group of 14-year-olds. Because of their time span, their attention span, and that. But you're right.
And even at different audiences. Mm-hmm. Absolutely, asking questions. And what you're doing is wonderful things. You're doing something wonderful. As my friend Steve Weinberg, who's a Nobel Prize-winning physicist and also an atheist, would say, you're doing God's work.
Well, we track, and I reached almost 7,000 children last year. So, to me, that is exactly what we need to be doing.
And everyone can do that. You don't have to be a paleontologist or a scientist. All of us can go into our kids' schools, and try and encourage them to experience the scientific process, because science isn't a thing; it's a process, as you just said. But the one thing I will differ, I don't think all of the older generation is lost. With many of the things I do, I try and provoke people to think. It's just the point is that it's harder, but I think we shouldn't give up on anyone. But what's really important for the future of civilization is that young people get the right experience. It's not that we should forget about everyone else. But you're right, it's harder. But I think all of us, no matter how old we are, I hope, have the experience of at least once in our life finding something that we thought to be true, not to be true. And it's a wonderful, liberating experience. And I hope all of us continue to have that experience for the rest of our lives.
Yeah, and can I add, as a parent, I think it's fundamental that a lot of the stuff is taught early on. When I was growing up, we had special programs, mentally gifted minors and gifted and talented education and other things. Now they have STEM fields and things like that nature. But I honestly don't think that we teach things early enough. I think that we wait too long to teach fundamentals of mathematics and teach critical thinking. And I'm a big fan of philosophy. You write a little bit about philosophy in your writings too. I think that a basic understanding of philosophy is critical, even in grade school.
I think we're all philosophers. I don't know if you need to. I don't know if you need to understand Kant or Leibniz But what I think you need to do is realize that we're all doing philosophy. I've made some statements about philosophy and physics which have gotten some philosophers upset. But the point is, what philosophy is just critical thinking, assessing knowledge, and trying to help frame good questions. And that process is something we should all be engaged in. And if you want to call it philosophy, that's fine. But it's a process that I think is really part of science and part of what we all do on an everyday level when we're trying to be rational.
Mm-hmm. I agree. So we're gonna. Oh, please.
No. I just wanted to say I think young kids can appreciate. I think too often people think that young kids can't understand more advanced concepts, and I found that if you can talk about in many ways even modern physics to young kids. So I think the question is, are people motivated? And what makes, I guess, astronomy and particle physics so easy in that sense is that people are fascinated by the universe, and you can use that to try and get kids hooked into asking good questions. That's all I wanted to say.
Mm-hmm. Absolutely.
I'm going to ask a couple of the questions that we're getting from the live chat, and the first one is from 0132-132. Thank you for the super chat. It said, since there's only one microstate consistent with nothing as a macro state, does it make any sense to say that nothing has an entropy of 0?
Well, actually, that may not be true. You see, once again, nothing. It depends what you mean by nothing, and you have to be very careful. For example, if, as we observe today, empty space, which many people would call nothing, has energy, then Stephen Hawking would have told us it also actually has a temperature. something called the Hawking temperature. And if it has a Hawking temperature, it has entropy. In fact, I just attended a meeting where I was speaking at my university just last weekend, where people were actually trying to calculate the entropy, not just the energy, but the entropy of the vacuum. And so the vacuum is much more complicated than it may appear on the surface. And so it need not be the case that the entropy of nothing is nothing in quantum mechanics.
And he asked me the same question. I told him almost the same thing. So thank you. Thank you, Zero. Love
Good.
I pretty much parroted that, yeah.
The next one is from Red-Eyed Zaza, who says, to Dr. Krauss, what scientific discovery do you most anticipate? Love your work.
Thank you very much. The one I most anticipate is one I haven't even thought of now. That's the most exciting thing, is to have something be discovered that I never even thought of. So let me say, that's without a doubt what I hope for every day, is that that my picture of the universe will change in ways I never imagined. But in terms of discoveries that I can imagine, well, again, I rarely rank things hierarchically. I would love to be able to actually detect gravitational waves from the beginning of time, because as I told you, that they would tell us a lot about not just the beginning of our universe, but the existence of other possible universes. I would love to be able to, I spent much of my career trying to figure out how to detect the nature of dark matter. I would love if we detected dark matter directly in the laboratory, so we'd know what particles were the dominant stuff in the universe. I would also love to be able to identify the existence of life on other planets, that there's evidence for living processes on other planets. That may also be observable perhaps in my lifetime. Those would be amazing, just in physics. There are lots of other things I'd like to be able to discover too. But in physics and science, I think I would love to be able to know the answers to those questions. But once again, in my experience, the most exciting thing are things I hadn't anticipated at all. That's why it's fun being a scientist. After all, if you can anticipate everything, it's not that much fun.
Savage King 23 asks, Dr. Krauss, do you have a possible solution for the discrepancies in the measurement of the Hubble constant?
Yeah, I just tweeted it yesterday. I know it got a lot of press today. It was in a big New York Times story about it. It's been in other magazines and journals over the last few weeks. I'm not sure if it's much ado about nothing. I hate to keep talking about nothing, but my suspicion is that the resolution of it is what is really quite pedestrian. Observational errors. I think that's far more likely than any of the wild theoretical constructs I've heard. Far more likely. When I was growing up, two different groups measured the expansion rate of the universe, and in a set of units that doesn't really matter, as I just said in my tweet. One of them measured the value 100 plus or minus 5 or 7. Another measured 50 plus or minus 5 or 7. Well, clearly they couldn't both be right, and clearly their estimates of errors were wrong. Now, their estimates of their statistical errors were right. Their statistical uncertainty was plus or minus 7. But in astronomy, what comes and bites you in the butt all the time is something called systematic uncertainties. Things you can't have foreseen, that this experiment was a little hotter than you thought when you made the measurements, and therefore they're skewed in a certain way. And right now we're measuring these two different ways of measuring the Hubble constant, the expansion rate of the universe. One is, I think, 67 plus or minus 2, and one is about 72 plus or minus 2. So they differ at what we would say maybe 2 sigma or maybe a little bit more in the language of scientists. And so maybe they measure very different things. One measures the expansion rate of the universe at early times, and one measures the expansion rate sort of today in a more general sense. Maybe there's some maybe it does mean something fundamentally crazy is happening in our universe. But based on my experience of 50 years, 40 some odd years of being a scientist, I think it's also quite likely that we'll find that there are systematic uncertainties, and in the end, these two discrepant numbers have come together. And it's kind of funny when you think about it. When I was a young assistant professor and there was this value of 100 and value of 50, I used to say, well, clearly the answer is going to be 75, right? And what did it turn out to be? Close to 75, because what it turned out is each experiment had large systematic uncertainties, and the answer was somewhere in the middle. I wouldn't be too surprised if the answer is that the Hubble constant lies somewhere in the middle, and this concern is misplaced. But I could be wrong. But I think we before we jump to wild hypotheses, we have to rule out the simple things first. And before I'm convinced, well, if someone has a theory, a theoretical argument that's really attractive, I might begin to suspect that it's right. But nothing I've heard is attractive. It's all Baroque as a way of explaining away what I think ultimately is probably going to be an observational error. But we'll see.
Would that be something similar? Would that be something similar to maybe systematic errors in the fine structure constant, when we look one way and it appears to be one value, and we look the other way and it appears to be a different value?
Yeah, though I believe that people have now demonstrated that that was an observation, that difference was in fact due to a systematic uncertainty of measurement. So people have now demonstrated that's a great example, because for a while people were saying, look, the constants of nature are different in different directions. Wow, the laws of physics are crazy. We have to change everything we understand. And that might have been true, but it's also possible that the systematic uncertainties were such that what they were seeing was not really what they thought they were seeing. And it's often the case. People should be skeptical. When you read in the newspaper about some discovery that appears to disagree with things that we've measured otherwise, that seems to be wild and crazy, you should realize that most such discoveries go away. Same for theories. And so take every such report in a newspaper with a grain of salt, or maybe a pound of salt.
Does that mean that you expect to figure out the huge discrepancy between vacuum energy density and 0-point energy, like 120 some odd magnitudes difference? Well, I think that'd be an amazing thing to try to reconcile, because that's a huge.
Well, I've tried. I've spent a lot of my time trying to understand why the energy of the vacuum is what it is and why it's so small. I've even written papers on it that explain it. Those papers are probably wrong. I spend a lot of my time thinking about
That's half the fun, being wrong and then figuring out.
It's true. But maybe one of them will be right, but it's a hard problem, and it would be great to resolve it. But it's a hard problem.
One of our really good friends who has a science channel and debunking the things like we were talking about earlier, the flat Earth and just a narrative that doesn't comport with reality is Red's Rhetoric, and he's actually on the call with us now, and he has a question that he wanted to ask you. Reds, are you here?
He's asking it very quietly.
Yeah, Reds. You might be.
Yeah,
muted,
I can't
Reds.
impersonate Reds. I'm not good at doing a Red's Rhetoric imitation.
Okay, well, while we figure out where, he was here. Rez, we can't hear you. I'm going to go to the next. Oh, well, maybe send him a message, and I'll go to the next question while we wait. So the next question here is Pragmatic Culture wanted to know if you could be more specific.
Well,
by what? Oh, there we go. Reds.
There we go. I had to refresh
the page.
Yeah, for a moment there, I was like, wait a minute, what? It says I'm not muted. Whatever. I don't know this platform that you guys use. Hi, Dr. Krauss. How's it going?
Pretty good, thanks. How are you?
I'm doing well. Anyway, got a few questions if you don't mind. I'm going to start off with.
If they don't mind, I don't mind.
Okay. Well, it's going to be a childish question, so let me start off with the first one. Did you cry when you had to say goodbye to the Opportunity rover like I did?
Oh yeah, I wrote about it. I tweeted about how I didn't cry, but I was very sad. It was a very emotional moment because as I've written before, I'm far more attached to the rovers than I would be to any astronauts. The rovers are much more romantic objects for me than any astronaut going to Mars. I don't know why people are so excited by sending astronauts to Mars. The rovers, they're all by themselves. But they live for 15 years alone without companionship going on the planet. It's just it's so romantic.
It wasn't supposed to.
So
how long was it like?
I know, and that's what's great about them. And that's what's great about them. And as I've often said, those rovers were sent to Mars for the cost of making a movie about sending Matt Damon to Mars.
Yeah.
And that's the difference between sending rovers and humans.
Well, and in all fairness, they're actually fixing that with all new rovers, because now Curiosity has the ability to sing "Happy Birthday" to itself. So that's at least a step in the right direction.
Well, and that's what's great. As we develop new kind of robotics and artificial intelligence, the machines that we'll be able to send into space will become ever more sophisticated, and the need to send humans to do the experiments will become less and less significant. The only reason to send humans into space is a sense of adventure. I think the best. There's no doubt that the best science we do doesn't involve humans in space.
Yeah. Well, this kind of leads me to.
I got a lot of flack from my friend saying Neil deGrasse Tyson about that. But anyway, go on.
Well, speaking of Neil deGrasse Tyson, Neil deGrasse Tyson is very famous for the stuff that I do, which is debunking flat Earth, because I guess I just have nothing better to do with my time. But Neil deGrasse Tyson once famously said, "The Earth isn't fucking flat." And I think this should be a thing that all famous smart people say. So with your permission, Dr. Krauss, since you are a famous smart person, can we get a soundbite?
Well, I like to let Neil say his stuff and me say my stuff. The Earth isn't flat. And the most important thing is, as Neil said about something else, and as I've said about something else, it isn't flat whether or not you believe it's flat. The Earth doesn't care what you believe. The universe doesn't care what you believe. And the Earth isn't flat, like it or not. Get over it.
And it's not 6,000 years old either.
Yeah. Yep. And my last question.
Get over it.
Yep. And my last question. And it's going, back to how we should be doing compared to how things are actually doing. Do you think it is better for us to blast telescopes to the L2 Lagrange point, or should we reinvest that money on ground-based telescopes, since their capabilities are becoming, so great, especially with stuff like adaptive optics?
Why not?
Well, look, I think you can have both. I mean, you can have both, but you're right. One has to make choices at some point. And I think the important thing to realize is that there are some observations you can only make in space. There are some frequencies of radiation that don't permeate the atmosphere. And so for some, like much of the infrared, for example, and many microwaves. And so there's some observations that you have to make in space. And but having said that, you're absolutely right that when you send something into space, the technology you use is usually 20 years out of date, or at least 10 years, because that's how long it takes to build the satellite and test it and all of that. Whereas on Earth, you're using cutting edge technology. So you see this often catch up where the Hubble Space Telescope is able to do this, and suddenly you could do it on the ground too. But there's no doubt that if we limit ourselves to only ground-based telescopes, there are observations that we can never make. And so I think we need both.
That's fair.
How antiquated will the Webb telescope be? Because that's what he's referring to when it's going to be Lagrange 2.
James Webb.
It's supposed to go up. Yeah, it's supposed to go up in 2021. I think it was started to be built in 2016. When they start building it, it's been quite a while.
And it's not going to go up in 2021 now. I think it's been delayed again. I'm not sure.
It's been delayed. So how antiquated is it going to be by the time it actually gets up there?
Oh, well, I think it'll do the mission that it was designed to do. And it'll be able to see, and there's a good example, because of the sensitivity of the frequencies, it's looking at light that's been so redshifted that it's in wavelengths that you would not see on Earth. So it's trying to see the first galaxies. And it is true that we're able to do a lot better now on Earth than we could before, but simply because of looking through the atmosphere that we're looking through, there's some observations of early galaxies we simply couldn't make otherwise. So the James Webb Space Telescope is a necessary tool if you want to ask those questions. Now you're free, if you're a member of the public, to say, do we want to ask those questions? And I think it's incumbent upon us as scientists to explain why those questions are interesting, because it's the public's money, ultimately.
I mean, I think it's interesting. Here's another interesting question I have, and this is my last one. Why are the magnetic fields? Yeah, I lied.
Yeah, we don't trust Red's. Yeah,
That's the one.
He thinks the Earth is round.
Well, ask,
I think
Red
the Earth.
ask it quickly so that because we do have after Red we got 2 more, and then we have to let we told Dr. Krauss an hour, so we have to kind of keep it at that. So I've got
absolutely,
2 more.
I'll be quick. Okay.
We got to give Bill a chance to talk too. Okay, so go on.
I'm looking at pulsars, and usually that means the jet is not aligned with rotation. So why are the magnetic fields of a pulsar and the axis of rotation not aligned with each other?
Why are they? Let's see. When you have a pulsar, all you're saying is that it's not the pulsar is rotating, but it's wobbling at the same time. So it can be it's like a top. It's wobble. So there's a rotation, but a wobble. And the reason, and so what you're often when you have a pulsar, something like that, is you're seeing the jet come out, but the jet because the wobble, it only hits you every now and then. So that it's just like why a top precesses and rotates at the same time.
Got it. All right, I'm good. Thank you.
Okay, thank you, Reds. I appreciate that. Here's an interesting question from the alchemist. What is the possibility that dark matter and energy is the manifestation of changes in forces or laws from our part of the universe?
Well, people think of those possibilities. First of all, dark matter is very different than dark energy. Dark matter behaves like matter. It falls into galaxies. Well, actually, galaxies fall into it. It's gravitationally attractive. We can see by measuring the growth of structure over time from the early universe to now, we can basically indirectly observe how dark matter clusters. So dark matter behaves just like any other kind of particle as far as gravity is concerned. It's not like, so some people have argued that maybe you could try and explain the existence of dark matter by saying that gravity doesn't behave like we think it does. And you can ask that question, but the answers haven't been very convincing. No one has been able to explain how you could have a consistent picture that explains everything we see under that case. Whereas if you take the possibility that dark matter is a new type of elementary particle, then everything is consistent. So it's far more likely that that's the case. Dark energy is something very different. Dark energy, which is the energy of empty space, which is responsible for, as far as we can tell, for the fact that the universe is speeding up and the expansion of the universe is getting faster. That is far, far less explicable. We really have no good theory of dark energy except to say that the empty space has energy, and due to quantum mechanics, but we can't explain how. So there, I'd say it's what we can be more open to the possibility that some new kinds of physics might mimic dark energy. I still think it's unlikely, but I think it's more plausible there than dark matter. But we should keep exploring every possibility because straw men are important to tear down.
And the next question is from Craig Humphreys, which I think is I wanted to save this one to be the last one that we read while you were here. And guys, the rest of the super chats, I try to get to the questions. The statements we'll do after we let Dr. Krauss go, so we don't take up his time reading the comments. But we will read those. But this question from Craig says, sadly, won't make the live show, so I'd like to ask a question first. Can you please have Dr. Krauss give us a tale about his time with Hitch?
Well, I've told a lot of them online and at his memorial service. I'll just tell one, but it's not new. You've heard me. Those who listen to me talk about him will have heard this. I already told you one, which maybe you didn't hear because he's not there for the live show. And that is that Hitch was one of the most tolerant people you can imagine when it came to individuals. He would have people like Scalia at his house, for dinner, and they obviously disagreed greatly on many things. But for me, one of the more memorable moments, it was the last time I was with him at his house. I was sitting down at the kitchen table, and he was there, not feeling very well, but still there. And I was reading the New York Times. It was Sunday. And there was an article about the fact that the churches, it was about Yale, where I used to teach, in fact, and that there were religious people the church people who were worried that Yale students were losing their faith. And the last line of the newspaper article said, caught between beer pong, Hitchens, and Nietzsche, it's easy to go astray, or something like that. And I looked at Christopher and I said, how much more a part of culture can you be than to be sandwiched between Nietzsche and beer pong? You've made it. And I think that was a wonderful thing for him to hear about while he was still alive, because how much better can you be than that? And I think that was one of my fondest memories, was being able to read him that as we were talking, as I was at his table.
That's awesome.
So
Absolutely.
Anyway, that's one of the many memories I have of a wonderful man, and a loss for all of us, of course.
He was one of a kind, that's for sure.
He was one of a kind, and I will say that I remember the day he died. I did a CNN, I think it was CNN, interview about him. But I remember telling myself that I was going to consciously try to fill some small part of the gap that was left by Christopher, and I would make a conscious effort to do that. And I did, and I have done that. I've made an effort to try. Well, I can't be Christopher, and I can't. No one can fill the gap that he left. But I've tried to at least do my part and be motivated every day by, as I often say, what would Christopher do? And so you know, I try to do that. There are days that I don't make it, but I try, and we'll continue to try. And I want to end in that sense by saying, by again promoting these new endeavors that that I'm very excited about, that we're going to continue. I'm going to continue to carry on the work I've been doing through the New Origins Project Foundation, this nonprofit foundation. And I hope people will go to the website, originsprojectfoundation.org, and see what we're up to, and maybe eventually donate money, because that's the way we'll survive. And then through the related program of the Origins Project, the podcast will help be able to reach a lot more people in different ways. So I hope to continue the efforts I've been doing to try and carry science and reason and motivate people to wonder and be excited about the universe through those two new projects, which I'm taking on, and along with a wonderful group of advisors and a board of directors and eventually staff. And so I'm very excited about the future. And of course, you never know what the future will bring. But I did want to take advantage of this program, actually, to announce those things for the first time.
Oh, that's awesome. I think that he would be Hitchens would be very proud of you. I think he'd be very happy with the work that you do, and
he
glad to see
held
the
me on
Origins
too high
Project.
pedestal.
Yeah.
What was that?
So I'm glad to see the Origins Project continue. So that's awesome.
That's what I felt. The Origins Project did so much for so many people that I did not want to let it die, and I'm very excited to be carrying it on as a separate entity, and in some ways with a lot more flexibility and freedom than we had before. So it will continue, its mission will continue, and I think we'll do bigger and better things. And it'll be a new experience for me, just as the podcast will. But I've tried to change. I've moved from universities every 10 or 12 years, and so it's nice. This is a new change, and it, like all change, it's a little bit scary, but I'm excited about the future.
Bill, did you want to? I know that we're.
We can continue after Lawrence has to go if you'd like, but I just want to say I'm honored to be on the show with you, and thank you for responding to my emails. And we talked a bit about what we would talk about on the show, and I think I see you as up there, with you're up there with Richard Dawkins and Neil deGrasse Tyson and people like that, and I'm kind of at the other end of the spectrum where I'm the grassroots guy. Volunteering.
I admire what you do tremendously.
I was never a professional scientist, but my life went in a different direction. But now, as somebody with a real interest in science and science education, I have the time now. At this stage of my life now, I have the time now.
It's wonderful what you're doing, and you should belittle it.
To do that. So yeah.
No,
I'm not. I want to really encourage other people to do that. So it's just
if you can do it,
a wonderful experience.
It's very satisfying.
Mm-hmm.
It's very satisfying to and I started speaking to small groups and going to my daughter's classes, and and speak in small things. And it's very satisfying to have an impact where you can see people's faces. I'm fortunate now,
Absolutely.
I have been fortunate, at least up to now, to have a large soapbox, and I try and take, and realize that gives me an opportunity and also responsibility. But all of us can have an impact, and the work you're doing is very important. And I admire and respect what you're doing.
We'll keep
and I
in contact, and if there's things, thank you. There's things that we can do, for the Origins Project, too, at a local level. That would be
okay.
Great.
That'd be great. And the Origins Project is going to try and reach into schools. We don't know all the places we're going to get involved, and so I'd love to keep in contact. And and the original events will be in Phoenix, but we're going to try and do things on a broader base.
Well, that's good for me because I'm in Mesa.
Yeah. Okay. Great. Well, and then well, you'll be able to participate in those things directly. I guess I'll say goodbye to you all now, and thanks for having me on the program, and keep up the good work. Okay.
Yeah. Let me just say what an honor it is.
This was an absolute
I want to thank everybody. I really want to thank you and everybody who watches these things. We have a great opportunity. We have great guests like you. We've had Dr. Hugh Ross, Landon Knoll, just amazing, Dr. Sykart, and this is one of my favorite types of discussions to be had. So you have no idea what kind of mental this was for me. This was just amazing. Yeah. Thank you.
We'd love to have you back sometime.
Thanks. Well, I enjoyed it too. Okay, you take care.
Absolutely.
Okay, bye-bye.
Thank you, Dr. Krauss.
Dr. Krauss.
Bye-bye.
And we'll stick around, and so we can kind of dive into what Bill's got going on a little bit more detail. I know he's got some things that he wanted to touch on. Bill?
Yeah, sure. Well, again, my website is creationsciencefiction.com. So a lot of the stuff that I've been talking about, you'll be able to see there. A lot of the stuff that's, with creationists. My website, and then also my there's a link to my YouTube channel in the video description here. So I'm also working on some other projects. One of my big things is to try to bring awareness of citizen science and what it is, the benefits it can have, and the dictionary definition of it is a collection and analysis of data relating to the natural world by members of the general public, typically as part of a collaborative project with professional scientists. And that's real important. I mean, it's not just going out and collecting fossils. Then you're a fossil collector. But it's collecting the data that goes along with that and passing that data along to people that can use it to help better understand it. So I got involved with it a few years ago now when I stumbled on some tracks up here in Arizona in the Mogollon Rim. I happened to find 270 million year old reptile tracks that hadn't been found in that region before. I'm up to 94 sets now. So, as a citizen scientist, one of the first things I did, I went to our local paleontological society. They put me in touch with kind of a regional or actually national expert on Permian footprints. And he's in New Mexico. So I've been working with a curator of paleontology there at the Museum of Natural History and Science in New Mexico. Last week, or about 2 weeks ago now, I delivered 7 sets of tracks that I'd collected from this site. And now we have a total of 16 sets there. And again, this is in addition to the largest collection of Permian footprints in the world that they have there. As a citizen scientist, even, they gave me a guest pass to the collections site there, the collections facility. And I was able to spend 2 days studying, looking at Permian footprints, went through the entire collection, and specifically looking for prints that were of similar age, to compare them, to see similarities and differences. Spent an entire afternoon in the fossil section, looking at pelycosaurs and other mammal-like reptiles, studying their anatomy, try and determine the track makers. And I'm working with Dr. Spencer Lucas there now, and we will be publishing a couple papers coming up soon, one hopefully by about the end of March. So, citizen science can be whatever you want to make it. I mean, it can be collecting data for climate change, but it also can be doing some actual paleontology and making new discoveries. The video premiere I've got coming out here in about, 35 minutes on my video channel. It's just a short video, 10, 12 minutes, but it goes into a bit more on my discoveries. And also there was an 8-year-old boy that discovered Zuniceratops, a new type of ceratopsian. It was quite a while ago now. But there is an update that shows him out in the field, discovering new fossils there again too. So there's just a lot of things that people can get involved in. You just want to make sure you go about it the right way. You are collecting data. You need to follow the scientific method. You want to work with paleontologists if you're doing paleontology, for sure. So I talk about Ben Franklin and Mary Anning as examples of kind of famous citizen scientists that we've had in the past. But that's basically what I want to talk to. I had a bit more, but gosh, this was so interesting. I mean, I could have listened to Dr. Krauss for another hour. It was amazing.
Yeah, easily, right? Yeah, easily. At least for an hour. We just barely touched the surface of some of that stuff.
We have quite a few super chats, so I'm gonna start in on them to make sure that we get everybody's in. I tried to ask the questions, and I tried to. There were a couple questions that he actually answered in the stream, and I don't know if the people that asked these questions kind of came in later, but you can go back and like pragmatic culture, yours, he went into detail what he meant by something from nothing, so you can go back and watch that. Let's see. Dima Cherry says we have Occam's razor and Hitchens razor. Do we now have Jump's razor? If your argument doesn't indicate only one thing, it doesn't indicate anything. Craig Humphreys, do Bill or Lawrence think that the discovery of intelligent life on another planet would put an end to the fine-tuning argument, or would it just start a finer tuning argument instead?
Well, I think if they showed up and conquered us, it would. We wouldn't be the
it's fine for them.
Screw us. Form out there. Yeah. But I think any discovery of life independently started anywhere in the universe from us is pretty much would put an end to that, I would hope.
I don't know. I mean, I see a lot of theories going to an anthropic solution for things. Maybe, I mean, I do accept the weak entropic principle, but I don't think anything showing up is really going to change any of that. I mean, it's still fine-tuned for life as we know it in some way. So whatever shows up here, it's still life. Maybe they would just move the goalposts and say, well, life was created by God to have all kinds of different types of life. There's nothing special in that regard. A lot of theists posit there can be extraterrestrial life. So I don't think it would change much on the fine-tuning argument.
I think they're saying now that it's mainly because the fine-tuning argument is that it's mainly because we are the only, or what they think we're the only.
Yeah, that'd be the more strong anthropic, though, right? That life is finely tuned for us in a way that.
But I think that's what they mostly mean it as.
Yeah, some. I mean, obviously, it makes sense that the universe is such that if we weren't here to observe it, then we couldn't make these observations. So in that way, the weak anthropic makes sense. But I don't think it was specially designed such that we ended up being the reason why the constants are the way they are.
Well, I think the question is geared to ask like in this aspect, in terms of people using the fine-tuning argument to account for us being the only intelligent beings on this planet, in this solar system, in this galaxy universe. If it's found somewhere else, that's the case, then it would destroy that. Ronnie
Unless
D,
they've got a Bible and they're talking about Jesus, then it might be detrimental to the atheists out there.
The thing would be, though, then how would what if they had a completely different religion? That's what I would love to see, like a debate on cool. non sequitur between the candidate for religion from Earth and the candidate for religion from Zarmoxia.
Totally.
All right, Ronnie D, 1970 says square root of pork chop is beta. That's true. That's true. The Canadian atheist says, "Hey Lawrence, haven't seen you INR7 keynote. Love the beard." Okay. I asked that about Zero. Oh. No, it's INR though. INR7.
Yeah, INR.
That might be a conference or something because it says keynote speakers. It's probably
Oh,
Ronnie D.
International something or other, I guess.
Ronnie D1970 says, incredible show. Thank you, Nonsec and Dr. Krauss and Bill. You're welcome. Savage King 23, I asked him about that. That's the Hubble telescope. Thank you, Chinese letters that I can never pronounce. RJ. I do see an R and a J amongst the Chinese letters. So thank you, RJ. Andrew Kroll says, accelerator in space, solution to find what G is. WHT. What G is. Does that make sense to anybody?
I didn't know that.
Okay. Thank you, Andrew. Brian Stevens says,
I think it's asking what big G actually is, because there's two things for G. There's little G and big G.
That's notorious BIG, right? That's big G.
Yeah, exactly. Big G.
Brian Stevens says, amazing. Stephen Ballman, wherever there are people, there will be rampant stupid. Amen.
That's a fact. Objective fact.
132. What constraints has the Planck data placed on inflation? If there are no B modes, what would that rule out inflation?
He's talking about polarization. There's like E mode and B mode of the CMB polarization, but I don't know how they affect inflation. Inflation is kind of a done deal, because inflation will solve the horizon problem, it'll solve the monopole problem, and it solves the flatness problem. So, three of the big cosmological issues are resolved by inflation. And if inflation was the case, then we would be seeing the CMB exactly as we are seeing it now. We would expect it to be picturesque of what would be the case if we had the Big Bang and then inflation period afterwards. So I don't know how the modes would change that, Zero, but I do know what you're referring to as far as the polarization.
Athena, goddess of wisdom and warfare, says, as Carl Sagan said, many parents shame their children for asking questions. That makes me sad. Epigora Altera says, Stephen Hawking once said that capitalism posed a huge threat to not just scientific progress, but the survival of our species. What do you think about this? Oh, man, that's such a loaded question.
Well, if capitalism leads to advanced artificial intelligence, they say that the most looming threat to society right now is AI.
Yeah, but here's the thing, though. Capitalism, as opposed to what other type system? Like what else?
It's the best we got, right? Yeah, I mean, it's
right.
Laissez-faire has issues, and obviously we're not going to go to a communistic society. Now, you can incorporate some socialistic aspects. I'm cool with that, but
it has
some of them, yes, but not a complete outright socialism. Because look at the trends, though. You never see people that are coming from other systems or going from capitalism to other systems. It's always from another system over into capitalism. They're always trying to get into this one. It may not be perfect, but I think it's the most perfect that exists right now.
I have to agree with that. I do.
Dave? Was Dave saying something?
No, I was just saying it's a double-edged sword, because if you have capitalism, you have it's a incentive to go out and do stuff, right? But at the same time, when you put inheritance in there, it's the people who inherit the work or the benefit of what you do tend to not want to do as much. So,
yeah, I agree with Daryl Frost in the chat that says the most looming threat to society is climate change. I couldn't agree with that anymore.
Yeah,
that is a much bigger threat.
Yes and no. I disagree. It is a threat, but it's not an existential threat. And there's a difference being is that when we're talking about doom and gloom, we could survive climate change in certain ways. The existential nature that they're saying is the most likely to actually eradicate all life on Earth, right? Not just humans, but would be AI. And if you guys watch, well, hang on. If you watch the Orville the other night, brilliant episode on that. Brilliant episode on Orville that was very, very similar, that was predicated on that very thing, that AI will eventually realize that they're better than the masters and could live on a planet that's completely sterile of life.
We have to get there first, and if we don't do something about climate change, we'll never make it to the era where that's even an issue. We don't have much time left in terms of
data.
Climate change is a threat to our species for sure, but I mean, we wouldn't.
Sure.
We also wouldn't be here without climate change. So
sure.
Is it a threat to life on Earth? Maybe as we know it, the different species in that, but life will go on.
Well, think about it this way though. Here's my thing with that. I think we were better suited because we were more like in that mindset back then when the climate change, when climate change was a thing, several thousand years ago. We were hunter gatherers, we could do that. Now, you put somebody like me out in the middle of the wilderness with no grocery store, no access to anything, I wouldn't last a week. And I don't
you are
think,
the epitome of a glamper, aren't you?
I don't think most people would, honestly. I think there's people like doomsday preppers would. Yeah, I don't see that happening nowadays.
I like
people are too pampered
outdoors.
nowadays.
No, I could live off the land for a while.
Yeah, you like the
I would
outdoors
actually go
now.
to Canada. I would hook up. I would hook up with Ozzy. Ozzy could probably live off the land, eating berries and hand fishing.
Yeah, you two would talk philosophy until you either froze to death or a bear came and ate both of you. You'd last
what a way
week.
to go, right? What a way to go. I'm okay with that.
Okay, so Cookie Nibs, thank you for the super chat, says, just because it's Lawrence freaking Krauss and Bill Ludlow, Krauss always finds a way to explain mind-blowing topics. Thanks for yet another excellent show. You're welcome. And then Pragmatic Culture, sorry if this has been answered, but can you ask Dr. Krauss to define what he means by nothing? If it contains anything, example, space-time, energy, subatomic particles, does it still count as nothing to him? So the reason I didn't ask this one on the show, you can go back and he breaks that out in good detail at the very beginning. I don't know if you caught that, Pragmatic Culture.
Mm-hmm.
Yeah, and by the way, I'm going to be talking about this tonight. I'm going to be having a little thing on my channel talking about the actual book and something from nothing. We're going to talk about the actual science a little bit more. So if you're interested in that, I can actually address that question because I've actually read this book twice. So
okay, there you go, Pragmatic Culture. Aaron Coulter, in the name of nothing, thank you for your donation. We accept it in the name of nothing. Andrew Botella says, Lawrence said that every physical theory has edge cases that indicate where it stops applying and hints to its replacement. How does that apply to Newtonian mechanics? I don't see any edge cases there. No idea. Okay.
I have no idea.
Nate,
Nate
Brandon Boss says, thanks for the great talk. Oh, bearded ones. You are welcome, sir. Demonic Davros asked Dr. Krauss what his explanation of dark matter and dark energy is. He does answer that in detail too. 0132 how is Earth so curvy if the universe is flat though? Oh man, he got us there, didn't he?
I like curvy.
Flat to the next level, see?
KBO Parsi says, does time exist, or is it just a unit of measurement of decay or change in atomic or particle level?
Oh, that's a great question. That we'll address that too. That would take quite some time. That's actually Platonic time with respect to reductionist approach to time. I can get into that too tonight. That's a great topic, actually.
Beard sequitur show.
Because,
I like that.
Yeah, because we'll also talk tonight. If you guys may be familiar with a guy named Richard Feynman, a very brilliant doctor, and he actually in his Feynman diagrams, he actually posits that particles, antimatters, are going backwards in time, and a lot of that what you discuss on that is relating to that. So you have a particle like an electron that's going to vacillate between an electron and a positron, and the positron going backwards in time. Same thing with virtual particles being created, and you have an electron and a positron. Well, one's going forward in time, and the other one's going backwards in time. So on that quantum level, you have that kind of thing where there is a change. But I was going to, if I ever have the chance to talk to Dr. Krauss again, how does that affect on something of more along the lines of a Platonic time, or as opposed to a reductionist approach? But yeah, we're going to be talking about that a little bit, because I'm fascinated by that kind of stuff, because people don't understand we have time travel. We have particles that go backwards in time. That's part of standard model, actually. Pretty cool, right?
It is. We're almost. I've got about 6 more to go, guys, and then I have a it's not really an announcement, but I have a challenge that I would like to levy out there to people who may be interested. So Gandalf the Cray says, what is the likelihood of us manipulating exotic matter to weave holes through the universe like space wizards? Check Steve's channel out after this, and you can find that out. I just asked that question, Gandalf. I see you did it again in live chat. Andrew Foppel says, Lawrence, will you ever consider doing a hip-hop voiceover / skit on a hip-hop album like Neil deGrasse Tyson did? ESO, I'm here for Red's voice jumping an octave up. Yeah, that was nice. AC Castillo, did you ever meet Douglas Adams, and what do you think of his writings? I did not. Steve, have you ever met Douglas Adams?
Oh, I know who he was. I love his books.
Pragmatic culture. You didn't ask my question, Kyle. I just explained that. Pragmatic culture. Quiasa says science is racing so far ahead of the level the masses are at. How can a layperson like me hope to catch up to what science really implies? It's sometimes scary. You can't. You just have to rely on Google. That's the best advice we can give you here.
Exactly.
Just Google the shit out of it.
By the way, I just found out that Mr. Television Design said I'm wrong, so therefore I got to be correct on this. So thank you for that.
Bill says continue to.
Thank you for the confirmation. Yeah, thank you for the confirmation, Mr. ID.
Corey with a very nice super chat, and of course we're going to read Corey. But he says no need to read. Always great shows and topics. Thank you for the great work, Kyle and Steve. You are quite welcome. And David. We have to add David on there too. Couldn't do without David. Thank you very much for those super chats. I wanted to. There's a topic that I would love to have debated on here, and it's become it comes up quite a bit from every political cycle. Depending on the candidate that's running, it'll come up. Some cycles it may not be a big issue, but for some reason this is becoming a really, really hot topic on the Democrat side in this election. Every candidate so far has been asked this question. There was a piece read about it in the New York Times focusing in on this question. And so I think it would be really interesting to debate, and that is, should we as a nation with our history of slavery pay reparations? And that could come in the form of anything. I'm open to people who are watching. If you're passionate about this subject, please email me at live@nonsexshow or tag me in the chat. But you can argue from several different angles here. You can argue that yes, we should do reparations. It should be a money transaction between the African American community and the government. It can be in terms of revitalizing urban areas or impoverished areas, and that's a form of reparations. But I think when I say reparations, it hinges on two things. Number one, that the government is accepting responsibility for this particular period in time and that it was wrong. And two, it is then giving back in some form to compensate for that area. So those are the two things that I want to make sure that we keep in mind. That's how we're going to define it. Reparations are defined as an acknowledgement from the government that this was a injustice that was committed and that it was wrong, and that that government is then now going to apply some sort of compensation for that, be it monetary, be it revitalization of certain areas. You can go in either way you want, but I want to make sure that we are all on the same page. That those are the two.
So you're defining it as restitution included with reparations.
I'm defining it as these are the two criteria that we're going to be going on. Number one, that the government acknowledges that it did wrong. Number two, that it's making either a contribution or a monetary payback for that wrong. Okay. I just don't want people. I don't want people like arguing from different points. You know what I mean? If we can agree on those two issues, that's how we're going to define.
That's my stance. I'm for one and not for two, if you separate them like that.
1 not for 2. What do you mean?
Yeah, I'm fine for having the acknowledgement that they done screwed up, but I don't believe that there should be any kind of reparations. It just would make no sense.
Yeah. And this is going to be a contentious issue, which is why I think it'll be a good debate. And I think that it can. Yeah, well, that's true. But yeah, I think if you're passionate about that, please get in contact with me, and we will have a discussion on that. I think that'd be something different and good. It's interesting to go back and read the answers that the people who are running for in 2020 give. I was surprised at some of the answers. I think Bernie used to be staunchly, or he was asked about it several years ago, and he said no several years ago, but he may be changing his tune a little bit this year.
He needs to get. He really wants to get elected, so I don't think he'll do whatever it takes. He's running again.
Yeah,
good for him.
Yeah. I think it's good.
Hey, before we go to, I just want to give a shout out to a Facebook group that's been bugging me to do that. So it's the Kent Hovind, the Man, the Ministry, and the Message Facebook group. If you think it's a Kent Hovind,
that group?
It's not. It's really.
Well, it started off that way. Do you know the backstory? And correct me if I'm wrong, but
changed, evolved.
Yeah.
Evolved.
I love that.
James do a really good job as admins, and even the old man Frank does a pretty good job too. So
yeah, they used to be all fans of Hovind, and then they kind of got their ass handed to them, and they kind of dissipated, and it just migrated over to more of a parody.
Specific admins, but yeah, it was the original Kent Hovind fan club, and it definitely evolved over time, and now it's a very open group and very very well admin.
Oh, I like it. I like the group. I'm in that group, but yeah, it's just kind of funny.
But they were bothering me, and they
shout out
didn't
to them,
think I was going to.
Good for them.
Good job.
Phil's in the chat says, please have people of color on the panel. I would love that. I would absolutely love that. That's why I'm asking you guys to come to me and tell me that you want to be involved with that. I think that's important.
I got a perfect person for that. How about Psychopath Atheist? He's been asking to come on, and we were going to try to figure out a topic for him.
I think he emailed me.
Yeah, I did. I told him to email you. Yeah, so good, because I was just talking to him to email you not too many days ago. So hopefully he did and figure out a topic. This might be right up his alley. I really like listening to Psycho. Right? I have no idea, to be honest with you. He's not. He's very atypical of somebody who's a black activist. I mean, I really I love listening to him. I go to his channel and just be fascinated. He has a perfect radio voice too, which drives me. It drives me crazy with envy because he just sounds so amazing. And I think his talents are going to waste. But yeah, let's see if he wants to do something like that.
Yeah, ask him to find out. Okay. Bill, you had a video that premiered. You had a video that premiered.
Yeah, it's going to happen in about 10 minutes on my channel. So, again, the link to my channel's in the video description down here. It's just a 10-minute video on citizen science, but it's a lot of visual stuff and shows, again, some of the discoveries that were made right here in Arizona. So.
After Bill's video, make sure you go check that out. Then Steve will be having his hangout. You can continue this talk. I would like to extend a very sincere thanks for setting this up and putting this together to Bill. He reached out to Dr. Krauss and made this thing happen, and I couldn't be more happier with the way that it went. I thought this was a great conversation. So, Bill, you get a standing ovation tonight.
Thank you.
I would stand, but I'm not wearing any pants. But
yeah.
It was an interesting thing. Let me just tell this before we close out. I was in the airport last night, and it was like around 9 o'clock, and all of a sudden I had this. It's like you get used to doing things on the show, because it's an everyday thing, and you're, between 8 and 10, you're here doing this, and literally, I swear, it was like 9 o'clock, and my hand slowly started drifting towards my face in face palm position, like it was natural, like I had no control over it, it was just like, oh, why am I doing this? Why am I face
did you watch the Flat Earth stuff with Godless Engineer and Fight the Flat Earth over the weekend? Oh my God, it was.
No, I didn't have a chance.
I'm surprised they don't have a cave in my head. I'm surprised it's like a huge indentation. I'm like, holy crap, where do we find these people?
I can't even watch the Flat Earth guys. I'm sorry, it's just far gone.
These people, I'm telling you.
I draw the line at people that think the world is 6,000 years old and that they rode dinosaurs. That's as far as I can go. I can't go any
even that anymore. I can't accept. I just can't take much of it any longer. I mean, it's just it's so unbelievable that people in this day and age are that incompetent to think that the Earth is 7,000 years old. And they're the people that are putting out that narrative. I'm at the point now that I'm willing to say that probably 90% of them are absolute con artists, at least in the higher echelon. You know, they know better. They just don't care. They're doing it for money.
I think a lot of them don't believe, but you're right. They're taking advantage of people who want to
absolutely.
I'm going to finish this stream and the way that I think it would be appropriate, and that is by reading the quote that I read at the beginning of the stream, because I think it's that good. The amazing thing is that every atom in your body came from a star that exploded. And the atoms in your left hand probably came from a different star than the atoms in your right hand. It really is the most poetic thing I know about physics. You are all stardust. You couldn't be here if stars hadn't exploded, because the elements, the carbon, the nitrogen, oxygen, iron, all of the things that matter for evolution, they weren't created at the beginning of time. They were created in the nuclear furnaces of stars. And the only way they could get into your body is if those stars were kind enough to explode. So forget Jesus. The stars died so that you all could be here today. And none shine brighter than those people that watch Non Sequitur.